We define potential energy as the negative of the work done by a conservative force. What do we mean by conservative? We mean that it's path independent. So it doesn't depend on the path we take, it just depends on our initial and final positions. This works fine for things like gravity. All that it cares about is our position in the gravitational field, so we can define a potential energy for gravity. It also works for spring forces. It'll work for other types of conservative forces like electrical forces. It doesn't work for things like friction. Because friction cares about the path. If I travel from one position to another via a short path, friction doesn't do a lot of work. If I travel via a longer path, it does more work, even though we end up at the same ending point and we start at the same starting point. So friction is a non-conservative force. All right, so that's how we define it. We define it as the amount of the negative work done by the conservative force. So the negative of the work done by the force as we go from A to B is defined as our change in potential energy, or our final potential energy minus our initial potential energy. Thinking about it here, if you kick a ball, it has some kinetic energy. As the ball ascends, the kinetic energy decreases and the potential energy, due to its presence in Earth's gravitational field, increases. That's why we define it as the negative, so that as you go up, you gain potential energy as the kinetic energy decreases. Then at the highest point, you have your maximum potential energy and your minimum kinetic energy. And then as you descend, you lose potential energy and it gets converted back into kinetic energy. There you go. Let's look at an example with gravitational potential energy to hammer that home with some actual calculations. For gravitational potential energy, it's the negative of the work done by the gravitational force, which gives us mg times our final position minus our initial position. This means that we can say our gravitational potential energy at any given point is mgy plus some constant depending on where we defined our zero. Since we get to choose where our y = 0 point is, we can just say that our gravitational potential energy is mgy. Let's say we have a 75 kilogram hiker ascending from the base to the summit, and we want to know, with respect to zero gravitational potential energy at the base height, so this is where we're going to set my y = 0 for zero potential energy, what is the amount of gravitational potential energy at the base of the hill, at the summit, and at sea level afterwards? All right. Reminding ourselves that our gravitational potential energy is mgy. We can say that for A, at the base, we're at y = 0. So if y = 0, then my gravitational potential energy, which is mgy, is just going to be 0. To save some space, I'm going to write this as ug. So that's it for A. For B, we're at the summit. This is 195 meters above sea level, or 147 meters above the base. That means my y value is 147 based on my choice of y = 0. This means that we can say that our gravitational potential energy is our mass of 75 kilograms times our gravity of 9.8 meters per second squared times our height relative to where we set our y = 0, 147 meters, which gives us a large number that evaluates to 108 kilojoules. So 108,000, converting it 108 kilojoules worth of gravitational potential energy at the summit. Last, we'll consider at the base, below the base at sea level afterward. If we're 195 meters above, that's 147 above our base, then 195 minus 147 gives us negative 48 down here. So this should be y = negative 48 meters. And that's taking this 195, subtracting off the 147, and we're left with that difference. So we have negative 48 meters, which means that our gravitational potential energy here will have the same things that it had before for mass and gravity, but will now have negative 48 meters. This gives us a negative number. Are we disturbed by having negative gravitational potential energy? Be honest. Are you disturbed? Does that make you uneasy to have negative energy? Sometimes I might have negative energy. The negative just means it's relative to where we set our zero. If we had set our zero down at sea level, then we'd have zero energy there, and then at the base we'd have a positive energy. So whether you have positive or negative energy just depends on our choice of zero, and we get to choose that. The difference always matters, and the difference will be the same wherever you set your zero. So as long as you set your zero and are consistent, your choice of zero won't matter for your calculations. It will work either way. Sometimes you can make your life a little bit easier by choosing a zero to make it so that it's convenient for you.